Hello friends, it's Divyat again. This is our communication part 2 video. So in part 1 video I have shown you the explanation of the whole circuit diagram. Look like this. So we are now going to see the practical model of this circuit. So here is our circuit. As you can see, this is too much wires there, but no, don't be afraid. I can explain you everything I have used. So here is our transmitter HDR433 MHz, or say, as I show you, I have 433. You can use as a 434 MHz also, not too much differences there for transmitter. And this is transmitter, and the transmitter needs always an antenna for transmitting the signal of 434 MHz from this. This is our antenna. Antenna is nothing but I have made it from the wound wire by winding on the pan or something and take it out from there. So this is our transmitter, RF transmitter and antenna. I can show you that the RF transmitter requires power, ground and etc. thing, which is already given behind this model of an RF transmitter. Ground, data, VCC, etc. So now you can easily give the supply ground from other side. This red wire indicates that we are giving supply of 5 volts, and this for antenna. Data comes from here for transmitting from HD12E encoder IC. So here our encoder IC is also there. As you can see, there is the encoder IC. Wires are there, I know. So as I show you before, the one part of the IC is fully grounded. This is jumper wires, nothing but used for grounding. Another some wires, and this wire is the data pins. I am taking away from here to show you more good. This is our HD12E encoder IC. As I earlier explained you, the encoder IC nothing but the parallel to serial converter. We have only one antenna for that purpose, so we are encoding into serial data. So the working is like that. This is a data pin, 4 pins. This is a transmitter enable pin. We must have to ground for the transmission enable, for transmitting the data. So now data I'm going to give you. Sorry, I'm going to give the data by grounding these pins, and from there the data will transmitted through this antenna by this transmitter, RF transmitter. So this data will be sent by the nearest antenna of 434, what you say, the megahertz, the receiver here. Here's the one, the receiver. As you can see, the receiver has much pin, but just like the transmitter side, behind this receiver there is a fully notification, or say notes, for the what you have to ground and give the supply, where you get from data things, etc. For example, we are giving here VCC data taking from these 2 pins, grounded through this black wire. Okay, so it's very easy, but we have to just identify the pin numbers of the encoder and decoder IC. So two data pins is taken from here. Here is our two data pins. I'm removing this. Okay, you can see now. Okay, this is one. No. Okay. Now we can see the one data pin, second data pin meeting at the D in, as I showed you before in the circuit diagram. And here is a 4 resistor, as we require 51 kilo ohm resistor for the purpose of the transmission receiving things. We are using this 4 resistor. One is 47k resistor, another is 111, means said to be 4 Ks. So 1 1 1 1 and 47 gives us a 51 kilo ohm, which we require for the transmission purpose. This is our decoder IC ST12D. D stands for decoder. So D here, decoder. So now, as I done here, we are grounding one sided, and now other side of encoder is also we are grounding, as we don't require any address, we just require data. So whole circuit is explained, and now for incoming power lines is like this. I have connected the one charger for this purpose, 5 volts, and through that positive negative terminals are taken, and I am now going to switch on. And here one LED, you can see here, this is a pin, what is said to be, this is an indicator, you indicated for the power. So I'm switching on the LED. As you see, power is on now, and the RF communication is occurring. Here is the data. As you can see that now, power is on, and now you are also seeing the output. Ignore the other LEDs because this is not connected. As you see, this is not connected, not just reflecting, not on, and this LED is on. 1 2 3 4, total is 4 LEDs. So 4 data taken from here, and a black wire for ground. So LEDs are connected in parallel. Now we are going to give some data things. Now I'm taking these data pins here. There's total 4 wires for 4 LEDs. If I grounding, wait a minute. If I'm going to ground these pins, this is for LED pins or data pin, then one LED will be off. One by one I'm grounding. Oh, that's the wrong pin. Not here, here. Second one is off, third one is off, and the last here I can pin it off. This is communication through RF. There is no any wire communication between these transmitters and receivers. This is communicated wirelessly from this red antenna wire to yellow antenna wire. So as you can see that all LEDs are off. Now I have to show you something. Now if I remove the RF transmitter enable pin, which is located on the decoder IC, not is decoder, that's encoder IC, at 14 number pin, we can verify that thing. So here our ST12E encoder IC here transmission enable pin is here, 14 number. If we are not going to ground this, then we can't able to transmit the data from our transmitter through here. So we can see that thing also there. Now this is our 14 number pin, and this is our what is said to be transmission enable pin. And now I am going to take it out. So nothing has happened there, no LEDs glow again. So if I take one of them, nothing happened because transmission is not enabled right now. So for that purpose I have to again ground this TE bar, active low transmission enable pin again. So as you can see, one wire is already out of the breadboard, and so one LED should be on. So I'm going to just touch to the ground, and there is it, one LED glow, as here one wire is out of the ground. As now, if again I'm doing that thing, just what is said to be transmission enable pin is ground again for transmitting, and now grounding. This is transmitting signal. I'm just grounding the one BT. So if I'm going to take all of them out, then all of them should be on. Green LED on, other LED on, other LED also is on. So do not touching here to ground, and now transmission enable pin is on. Now if I'm going to take it out, transmission enable pin, and now I'm going to ground this LED, nothing will be happen, nothing will be changed at the receiver side. As you can see, nothing, no one LED is, we are not transmitting any signal because of this transmission enable pin, which is located at 14 number. Now if I'm going to grounding any data, or say to be sending any data, I have grounded two wires, jumper wires for that purpose. Now I'm going to take this pin 14, or say to be transmission enable pin. So as I grounded two pins and two I have left out, the two LEDs should be off. Now I'm going to just touch, and there is it, two LED is off. As you can see the Y side of these LEDs. So here, this is a important feature of this transmitting medium, or what is said to be transmission thing. So now, as you know that thing, so by this you can make a various other circuit for this purpose. You can communicate with microcontrollers, old, just like 8051 or something like that. Latest is Arduino Uno, which has this just like C programming language for that purpose, and make cool things wirelessly, send data to one to another part by just connecting through it to the transmission RF transmitters, or say to be RF modules. This is very cheap than GSM and other things, and range is also good compared to IR, which is infrared communication for wireless things, and this have a more range than infrared thing. And also obstacle cannot be interrupt the communication between the RF receiver and the transmitter. Because of this, infrared disadvantage of infrared thing is overcome, as no obstacle is any interrupting anything. So instead of these LEDs you can what is said to be connect relays and any IC just like ULN 2003 for the relay driver IC for driving the relays and control your home appliances also. So this is simple and good circuitries, and you can see that the thing is simple for transmitting things, data bits, etc. So now you can be made by yourself. So thank you for watching this video.